Hello learners, it is a pleasure to have you all here. In the last lecture, we discussed about the configuration, advantage, disadvantage and key differences of internal combustion engine and electric vehicles. So, in the previous lecture, we have seen a set of advantages and disadvantages are associated with electric vehicle, and a set of advantages and disadvantages are associated with internal combustion engine vehicle. So it will be really very interesting to see if these two vehicle technology can be combined together, and in what sense and in what way they are complementing each other to take care of their disadvantages and to strengthen their advantages. Therefore, today we will be focusing on hybrid electric vehicle. This topic is very crucial for understanding the operation of hybrid electric vehicles and associated technologies. A hybrid electric vehicle is a type of vehicle that combines two or more power sources for propulsion. Typically, an hybrid electric vehicle combines an internal combustion engine fueled by petrol or diesel with an electric propulsion system which includes an electric motor and battery along with the power electronics converter that we have already discussed in the last session. So, a hybrid electric vehicle when combines two different powertrain or two different power source, then it comes out with different modes of operation. It can be categorized in several categories. Some of them are mentioned and discussed here. In mode 1, energy source A and B both supplies to load simultaneously. For easy understanding, one can understand that energy source A, which is indicated in red color, represents the IC engine based powertrain, and energy source B, which is represented in a green color, represents the electric propulsion system based power train. IC engine based power system are unidirectional in nature, and electric propulsion system based power system are bidirectional in the nature. So in mode 1, both the source supplies power to the load which is coupled to the wheels of the vehicle. In mode 2, energy source A supplies power to the load and energy source B remains idle. In mode 3, energy source B or electric propulsion system based power system supplies power to the load and energy source A remains idle. In mode 4, energy source A supplies power to load and energy source B. In mode 5, energy source A supplies power to energy source B, and in mode 6, energy source B receives power from load. This is the scenario of regenerative braking or deceleration, where because of the inertia associated with the vehicle or momentum of the vehicle, the motor acts as a generator and it recovers the energy and it fed back to the battery to restore it, and that's why this electric propulsion system is shown as bidirectional. The energy recovered during regenerative braking can only be stored or supplied to electric propulsion system, and it can be stored in the battery connected to electric propulsion system. In mode 6, energy source B receives power from energy source A and load simultaneously. So these are 6 to 7 different modes in which the hybrid electric vehicle combines the power from IC engine and electric propulsion systems. The operating modes are not limited to this 6 or 7 modes that have been mentioned here. Few more modes can be derived, but these 6 to 7 modes are popularly being used in hybrid electric vehicle. Now let's focus on the load power and how it can be decomposed in two different components. So the figure A shows the load power. It can be divided into two parts, the average power, or we can call it a steady state power, and the dynamic power, or we can call it a transient power. The power requirement for typical driving scenario is very much similar to the graph that is shown in figure A. The load power can be decomposed as steady state power, the power with constant value, and the dynamic power, the power whose average value is 0. In hybrid electric vehicle, one power system supplies the steady state power or a constant power, whereas the other power system supplies the dynamic power or power required during transient. The total power output from the dynamic powertrain will be 0 in whole driving cycle. Generally, electric motor are used to meet the dynamic power demand, and IC engine backed power system are used to supply the constant power. This hybrid drivetrain concept can be implemented by different configurations as follows. So this image shows the configuration, detailed configuration of hybrid electric vehicle along with its different parts. Hybrid electric vehicle contains a battery, two types of battery. One is the auxiliary battery, another one is a traction battery. So in auxiliary battery, the low voltage supply are taken care by it. It supplies electricity to start the car before the traction battery is engaged. It also powers the auxiliary load of the vehicles. Second component is a DC to DC converter. This device converts higher voltage DC power from the traction battery pack to the lower voltage DC power needed to run vehicle accessories and recharge the auxiliary battery. Another component, important component, is the electric generator. It generates electricity from the rotating wheels while braking, transferring that energy back to traction battery pack. Some vehicles use motor generators that perform both the drive and regeneration function, and in some vehicle a separate generator and separate motors are used. Another important component is, in this particular case, we are keeping separate generator and separate motor. So another important component of a hybrid vehicle is electric motor. It uses power from the traction battery pack. This motor drives the vehicle's wheel. Some vehicles use motor generators that perform both the drives and regeneration function. So again, I am repeating the same thing. Either you can have a single machine which can act as a motor as well as a generator, and to minimize the complexities, two different machine, one act generator and one motor can also be taken. Another important component is exhaust system. The exhaust system channels the exhaust gas from engine out through the tailpipe. A three-way catalyst is designed to reduce the engine out emission within the exhaust system. Next component is a fuel filler. A nozzle from a fuel dispenser attaches to the receptacle on the vehicle to fill the tank. Fuel tank, this tank stores petrol or diesel on board the vehicle until it's needed by the engine. And another most important component of hybrid vehicle is the internal combustion engine vehicle. In this configuration, fuel is injected into the intake manifold or the combustion chamber, where it is combined with air, and the air fuel mixture is ignited by the spark from sparking plug. Another important component of a hybrid vehicle is power electronics controller or converter. This unit manages the flow of electrical energy delivered by the traction battery, controlling the speed of the electric traction motor and torque it produces. Another important component is thermal system, responsible for cooling of different on-board component. This system maintains a proper operating temperature range of the engine, electric motor, power electronics and other components. Another important component is a traction battery, the powerhouse of the electrical powerhouse on board. It stores electricity for use by the electric traction motor, and then transmission. The transmission transfers mechanical power from the engine and or electric traction motor to drive the wheels. So, in this different component, certainly you have seen the combination of the component that you have used in IC engine vehicle and some of the component that we have used in electric vehicle. Both the vehicles component has been combined together to get the hybrid electric vehicle. So, the vehicle that comes out by the combination of the IC engine vehicle and hybrid vehicle has its own set of advantages. So, let us have a look of different advantages of hybrid electric vehicle. First advantage of electric vehicle is improved fuel efficiency. The sole purpose of hybrid electric vehicle or the combination of the IC engine vehicle and electric propulsion system helps in enhancing the fuel efficiency, and it further optimizes the fuel's efficiency by combining and controlling the different operating modes of internal combustion engine and electric propulsion system. This combination also helps in reducing the emission. Hybrid vehicle produces lower emission compared to conventional IC engine vehicle, contributing to improved air quality and reduced greenhouse gas emission. It offers regenerative braking to capture and store energy during braking, converting into electricity and improving overall efficiency of the system, or adding few more energy to the onboard energy storage system. It has lower operating cost. Hybrid vehicle typically have lower fuel cost and reduced maintenance expenses compared to the conventional IC engine vehicle, as the electric motor assists the internal combustion engine, reducing wear on components. It offers higher driving range. The combination of IC engine and electric propulsion system offers a longer driving range compared to the pure electric vehicle, and it also gets the benefit of government incentives. In many regions, government provides intensive and tax credit for purchasing hybrid vehicle, making them more financially attractive for consumers. Though it offers several advantages, but it has going through a technology transition. Hybrid electric vehicles serves as a transitional technology between traditional vehicle and fully electric vehicle, allowing consumer to adopt more fuel efficient options while electric infrastructure continues to develop. So, these are some of the major advantages associated with a hybrid electric vehicle that comes out by combination of the two different power train. However, there are several disadvantages associated with the hybrid electric vehicle, and some of them are higher initial cost. Hybrid vehicle tend to have a higher upfront cost compared to traditional vehicle, mainly due to the added cost of the electric components and battery. Limited electric only range. Most of the hybrid electric vehicle have limited electric range, relying primarily on the IC engine for longer distances. These limitations may not suit those looking for all electric driving operations. though in one sense we can say it is most of the hybrid electric vehicle are IC engine backed electric vehicle, and that is why the IC part is dominating and electric vehicle part is on assisting side in vehicle operation. Another disadvantage is the battery degradation. The similar way that we have in electric vehicle uses battery that may degrade over time, affecting performance and efficiency. This battery replacement cost can be a major concern associated with hybrid electric vehicle as well as electric vehicle. Again, dependency on the fossil fuels, as I mentioned earlier, the hybrid electric vehicle is mostly IC engine backed electric vehicle. So, major part of it takes the petrol and diesel, and that's why the dependency on petrol and diesel remains intact, and it raises the severe, and it causes the severe environmental impact because of the tailpipe emission. It has complexity. Hybrid electric vehicle have more complex drivetrain with both internal combustion engine and electric component, potentially leading to increased maintenance cost and technical challenges. Certainly, we are combining two vehicle segment, and this combination will add complexities in interoperability of the component as well as proper coordination and communication among the component and its synchronization to deliver the intended objective of vehicle operation. It requires charging infrastructure. If the onboard battery is not sufficiently getting charged from the onboard IC engine vehicle, in that case one may require external charging infrastructure, but in most of the cases the onboard energy storage system extracts power from the internal combustion engine only. So, sometime you may require charging infrastructure or sometime you may not require charging infrastructure. Another disadvantage is increased weight. The additional component including the electric motor, battery can increase the overall weight of the vehicle, affecting performance and fuel efficiency. Less tailpipe emission reduction. While hybrid electric vehicle reduces emission compared to traditional vehicles, they still emit some pollutants from the internal combustion engine, limiting their environmental benefits compared to the fully electric vehicles. So, these are some of the disadvantages associated with the hybrid electric vehicle, though it seems very much similar to the electric vehicle. However, there is a trade-off between the advantages and disadvantages, and by the degree of hybridization defines the extraction or degree of the benefit that you can get from this hybrid electric vehicle. So, based on the degree of hybridization of the hybrid electric vehicle, it can be categorized as micro hybrid vehicle, mild hybrid electric vehicle and fully hybrid electric vehicle. So, if we like to compare all these three hybrid electric vehicle in terms of their IC engine size, then in micro hybrid vehicle it has a conventional IC engine, in mild hybrid IC engine is downsized, and in full hybrid electric vehicle the IC engine is further downsized and it has a good size of electric propulsion system. If we talk about the motor power, micro hybrid has 3 to 5 kilowatt of motor, mild hybrid has 7 to 15 kilowatt and full hybrid gets more than 30 kilowatt of motor. If you see the motor voltage, it has micro hybrid has 12 volt, mild hybrid has 60 to 200 volt, whereas full hybrid has 200 volt to 600 volt. If you see the degree of hybridization, then micro hybrid is less than 10%, mild hybrid is somewhere around 10 to 30% and full hybrid is greater than 40%. Greater than 40%, you can see the 60% is being contributed by IC engine vehicle and 40% is contributed by electric propulsion system. If you see it in terms of energy saving, micro hybrid saves 5 to 10% of energy, mild hybrid saves 20 to 30% of energy, whereas full hybrid saves 30 to 50% of energy. If you compare these three different types of hybridization of electric vehicle in terms of their function, then micro hybrid electric vehicle are used for start, stop, regenerative braking and accessories powering. Mild hybrid electric vehicles are used for frequent start, stop, regenerative braking and to supply the auxiliary load and to provide the electric propulsion system assisted drive. In a full hybrid, it can be used for frequent start, stop, recovering energy during regenerative braking, and it can act as full electric traction, or it can or the fully hybrid electric vehicle can be driven as a pure electric vehicle as well. If you compare all three categories in terms of the cost, micro hybrid is relatively low cost, mild hybrid is medium, and full hybrid involves higher cost. As the degree of hybridization increases, the cost of the system increases. Some of the commercialized vehicle in this categories are for micro hybrid we have Mercedes Smart, for mild hybrid it is Honda Insight, and for full hybrid electric vehicle Toyota Prius. So this is a detailed comparison of different hybrid electric vehicle in terms of their degree of hybridization. I hope this comparison gives you good insight about the hybridization and in its impact on vehicular operation. Another important segment in a hybrid electric vehicle is the power flow control. Due to the variation in a hybrid electric vehicle configuration, different power control strategies are necessary to regulate the power flow to or from different component. All the control strategy aims to satisfy following goals: to maximize the fuel efficiency, to minimize the emissions, to minimize the system cost, and to give a good driving performance. So this objective has to be taken care while designing the power flow control. These are the four objectives which are essentially important in a design of power flow control, or in another term we can call it a power management system for hybrid electric vehicle. So till now we have seen the working, operation, advantages, disadvantages and different degree of hybridization of the vehicle. Now let us see the types of hybrid electric vehicle, what are the different types available in hybrid electric vehicle. These are series hybrid electric vehicle, parallel hybrid electric vehicle, series parallel hybrid electric vehicle and complex hybrid electric vehicle. These types are derived based on the combination of the two sources. If two sources are coming together, it can be connected in series, it can be connected in a parallel, it can be connected in series parallel manner, or it can be connected in a complex fashion. So each of these connection lead to a new segment of vehicle architecture and configuration, and based on their combination these names have been given to respective vehicle configuration. So the first category or first type of hybrid electric vehicle is series hybrid electric vehicle. A series hybrid electric vehicle is a type of hybrid vehicle where an internal combustion engine is used to generate electricity, which is then used to power an electric motor that drives the vehicle's wheel. In a series hybrid configuration, the internal combustion engine does not directly drive the wheels but operates as a generator to produce electrical energy. The electrical motor, often accompanied by battery or other energy storage system, is responsible for providing the primary propulsion for electric vehicle. In another terms, one can say that the series hybrid electric vehicle is IC engine assisted pure electric vehicle. So this is the architecture or configuration of series hybrid electric vehicle, where the different component like fuel tank, internal combustion engine, generator, power electronics converter, battery, electric drivers, electric propulsion motors, everything is connected in series and power flows through all these components. So let's delve into the operation or functioning of series hybrid electric vehicle. Series configuration features an internal combustion engine, as you can see in the image, mechanically coupled with an electric generator connected to an electric motor and electromechanical battery pack via power electronics converter. The generator converts the mechanical power from the IC engine into electrical power, which can either charge the battery or directly power the electric motor for propulsion, or both together. Power flow from the fuel tank to power electronics converter is unidirectional, while power flow from the battery to electric motor is bidirectional, making it an IC engine assisted electric vehicle with no mechanical link between the IC engine and wheel. That is the important point that we all should notice, and note that in series hybrid electric vehicle there is no mechanical coupling between IC engine and wheels of the vehicle. IC engine start and stop are controlled by the battery's state of charge. The IC engine starts when battery state of charge reaches to its preset minimum value, and IC engine gets off when battery's state of charge touches to its desirable maximum SOC level. Power supply to the wheels involves two stages of power conversion: mechanical to electrical and electrical to mechanical, leading to increased energy losses and reduced overall efficiency. However, the mechanical decoupling between the engine and wheel increases flexibility and reduces overall complexity. The series configuration offers simplified construction, simple control strategy and reduced cost. It eliminates the need for multi-gear mechanical transmission system, but faces challenges such as the addition of generator and increased size of the propulsion unit. It is best suited for city driving with frequent start and stops. It is also best suited for the heavy vehicles like bus and trucks, which require a constant power, where the IC engine can be placed to its optimum operating point, delivering a constant power, and the constant power can be delivered to the motor via power electronics converter, and the motor drives these heavy vehicles at a constant speed, and whenever there is a transient takes place, the additional amount of power can come from the battery to compensate. The series hybrid electric vehicle involves different mode of operation. These operating modes are: in mode 1 or during startup, normal driving or acceleration of the series hybrid electric vehicle, both the IC engine and battery delivers electric energy to power converter, which then drives the electric motor and hence the wheels via transmission. In mode 2, at light load, the IC engine output is greater than that required to drive the wheels, hence a fraction of the generated electrical energy is used to charge the battery. The charging of the battery takes place till the battery capacity reaches to a proper level. In mode 3, during braking or deceleration, electric motor acts as a generator which converts the kinetic energy of the wheel into electricity, and this is used to charge the battery, and significant of energy can be recovered during this mode of operation. In mode 4, The battery can also be charged by IC engine via the generator even when the vehicle comes to a complete stop. So the series hybrid electric vehicle is operated under this 4 mode and drives the vehicle in a different driving cycle, maybe in traffic operation, highway cruising, hill climbing, highway acceleration, whatever may be the driving scenario. These different modes can be taken either in a sequential manner or any random manner to cater the need of particular driving profile. The series hybrid drivetrain are less common than parallel or series parallel hybrid in commercial vehicle due to its efficiency concern and more number of parts, but they are still used in certain applications where their advantages can be maximized. Here are some examples of commercialized series hybrid electric vehicle that use or some of the commercialized hybrid electric vehicle that use series hybrid powertrain configuration. Chevrolet Volt, BMW i3 with range extender, Fisker Karma and Proterra electric bus. These are some of the model which utilizes the series hybrid drivetrain configuration. So let's have the comparison of two most popular series hybrid electric vehicle. One is BMW i3 and another one is the Chevrolet Volt. If you compare their launch date, BMW i3 launched in 2013 and Chevrolet Volt launched in 2010. Electric motor, it has 125, BMW has 125 kilowatt and Chevrolet has 111 kilowatt. If you talk about the battery capacity, it has 22 kilowatt hour for 2014 to 2016 model and 33 kilowatt hour for 2017 to 2018 model, and in both the version it uses the lithium ion battery pack, whereas the Chevrolet uses 16 kilowatt hour lithium ion battery pack. It has 130 to 160 kilometer all electric range and Chevrolet offers 35 to 40 miles as all electric range. Another important term is this: if you see the IC engine capacity, BMW i3 has 647 cc 2-cylinder IC engine, whereas Chevrolet Volt has 1.4 liter 4-cylinder IC engine. During the extended range operation, BMW i3 can run up to 150 km and Chevrolet can run 300 miles. If you see the electric consumption, it consumes BMW consumes approximately 15.2 kilowatt hour and Chevrolet consumes approximately 36 kilowatt hour per 100 mile. If you see the fuel efficiency, it has 39 mile per gallon, whereas Chevrolet has 37 to 40 miles per gallon. If you compare their acceleration, it can go 0 to 60 mile per hour in 7.2 seconds, whereas Chevrolet can go 0 to 60 mile per hour in 8.5 to 9 seconds. If you compare the top speed, the BMW i3 offers 150 km or 93 mile per hour, whereas the Chevrolet offers 100 mile per hour, and both offers regenerative braking. So that's all associated with the series hybrid electric vehicle. I hope you all have got good understanding about the hybrid electric vehicle, its operating mode, its combination, followed by the architecture and configuration of series hybrid electric vehicle, its operation, different component, advantage, disadvantage, along with a short case study on some of the commercialized series hybrid electric vehicle. Thank you all for joining today's lecture on the hybrid electric vehicle. As we move forward, remember that hybrid electric vehicle represent a significant step in our journey towards sustainable and efficient transportation. The knowledge you have gained today will be vital as we continue to explore more advanced topic in this field. Stay curious and keep exploring and keep learning. Thank you.